Okay, so it's always going to be in that range. You adjust the range by putting some numbers in there. So if random is going to return a value between 0 and just under 1, and you multiply that by 6, then you know you're going to get a value of between 0 and just under 6. If what you want is a value between 1 and 6, you got a problem because using floor knocks that down. Even if it's 5.999, still knocks it down to 9. So that's why we add the 1 at the very beginning. And that basically returns a number like it reads. It's going to return a random number between 1 and 6. So that's readable. Now, there are different ways of doing this. You could use math.ceil, which would round it up every time, but then you've got to adjust it on the bottom end, and it doesn't read correctly, actually. It doesn't read the way it comes out. So this particular way reads the best because it reads between 1 and 6, and that's actually what you're getting. But like I said, there are other ways of doing it. It's just that this one reads the way it performs. This simulates rolling of a dice, a 6-sided dice. The statement is always assigned an integer at random. The variable face in the range of 1, I don't know why it's saying pound, face to 6 pound. I'm not sure what that stands for other than the British pound, but anyway. Referring to the preceding statement, we see that the width of the range is determined by the number used to scale. The operator 6 in this case, it's really, 1 to 6, basically. So when you see something like that, you can easily read it and know it's 1 to 6. Or it could be 1 to 10, you just make this times 10 instead of times 6. Now, if you wanted a number between 3 and 6, and you make this a 3, the 1 becomes a 3. And we can generalize the result as something like this. This will give you a result between A and B. A is the shifting value, and B is the scaling value, but really what it means is you're going to generate a random number between A and B. That's the way you would read it. Another example here, craps game. Let's take a look at this one. And see if I have this one. I'm not sure that I do. Craps. So this one here actually is pretty cool. When it tells you it emulates craps, I'm not really sure how to play craps, but we'll look at it. Their example here. We'll look at the code here in a moment. Let's take a look at the code here. We'll do that. So they have different versions here of play, roll the dice. Start the game. So the button down here, on click equals play. So that's going to call this guy right here to play, which will get the element for the point field, get the field, the reference field for the status. If it's the first roll, it does one thing. If it's the second roll, it does something else. I think in their new version, it looks like they actually divided first roll and second roll a little differently. It doesn't really matter, and the roll die is the same. Yeah, they have the images. I don't have the images. It just shows you the actual number. And the click is going to call the play. Calls roll die to get a value from the die that's being rolled, which is two random numbers between 1 and 6. Roll again. I really don't know the rules rules for die, so I'm not sure this is right. But those of you who know the rules can check it out. But ultimately, it's gonna, every time you roll, it'll tell you what score you get. Okay, any questions so far? Alright. Some new stuff for HTML5, the audio element. Is used to embed audio into the web page. We can specify an ID for this element so that we can programmatically control when the audio clip plays based on the user's interactions with the game. We can set the preload attribute to auto indicate to the browser that it should consider downloading the audio clip so that it's ready to be played when the game needs to be. And most browsers support MP3, OGG, and WAV format and/or WAV format. Each source element specifies a source and a type attribute. The source attribute specifies the location of the audio clip. The type attribute specifies specifies the what type of media it is. When a browser that supports the audio element encounters the source element, it will choose the first audio source that represents one of the browser's supported formats. Variables declared inside the body of a function are known only in that function. If the same variable names are used elsewhere in the program, they will be entirely separate variables in memory. Okay, I'm not sure why that got stuck in there. Initializing variables when they're declared in functions helps to avoid incorrect results. And we see that a lot. That is a good idea. In these source programs you see up here, declaring the variable and then initializing a value, declaring, initializing. Generally that's considered a good idea. Craps rule.html in the video element. Alright. Let's see. Actually, I think I've got these ones. Hold on for a second. Okay, here's a diagram we have. And let's see, it looks like we can play it.
Let's take a look at the basic rules for the dice. If on the very first roll of the two dice you get a 7, then you win. If on that first roll you get a sum that is 2, 3, or 12, the red squares, you lose the game. For all other values, you get what is called your point. The roll of the dice that we roll a 3. That value becomes my point, and now I have to make my point before rolling a 7 on a subsequent. If I roll my point value, I win the game. If I roll any other value,
Okay, so you can see if we look at the source code how simple it is to just include a video image in there. So that's a new tag that you have with HTML5. In the past, you had to use some sort of MP3 player of some kind to do it. Right, so not much to it. Much simpler now. Each identifier in a program has a scope. The scope of an identity identifier for a variable or function is the portion of the program in which the identifier can be referenced. Global variables or script level variables are accessible to any part of the script that are said to have global scope. Thus, every function in a script can potentially use the variables. So, getting back to our example here, these variables that are declared outside of a function are all considered script level or global, but the variables declared in here can only be used within this function. So that's the scope rule. So these variables here can be used everywhere. And we see that first roll, for example, is declared out here and we use it in this function. And we don't, in this particular first roll, we don't see it so much. So we can see how these ones here are then used in here. Whereas a variable declared inside of here, like status div, I would not be able to use it anywhere outside of here. Those would be those scope rules. Identifiers. Function scope begins with the opening left brace and ends with the right. Local variables of a function and function parameters have function scope. If a local variable and a function has the same name as a global variable, the global variable is what we call hidden, meaning that the local variable is the one that's used. You want to avoid having local variable names that hide global variable names. The best way to do that is to use different naming conventions, like use a shorter name for local variables and a longer name for script-wide or global ones, or even capital letters. So here we have some different functions to show you scope. This one. And those are the images. Okay, scope. I need to get these. I'm pretty sure I do have this one already. Hold on for a second. Yes. So here's the scope one as well. Again, we can look at this. Show you what's happening here. Well, why isn't it showing us? We'll use this one instead. Okay, so we create variables output and x here is equal to 1. Start initializes x to 5, then it calls function a b twice. Then it outputs the value of x. Now what we'll notice is that in function a, redeclares variable x and sets it to 25. Then it outputs it, adds 1 to it, and outputs it again. So we should get 25. With a, we should get 25 and 26, which is what we get, 25 and 26. For b, however, does not declare its own variable 25. So b starts with the variable x equal to 1, outputs it. I don't know why we're getting those values. It should start at 5. Multiply it by 10. 10 don't seem right. Make sure we get the right source here. X equals 1. Start. X equals 5. Oh, so this is going to be x equals 1 each time. In here, locally, it uses the local variable 25, so we're good there. Self times 100 10. Local variable is 5. Okay, we know that. Okay, so honestly, I'm not sure why it's giving us 100 and 1000. It's initialized to 1. Unless I'm missing something here. When function b is called, it should be 1 and 10. Then it should be 10 and 100. Yeah, this one is correct. Something does not seem right, though. So I don't get confused.